Good day, everyone. So today I will be presenting the work of Group 6 for math in the field, primarily in the field of nutrition. So first, it is entitled Linear Optimization for the Perfect Meal, a data-driven approach to optimizing the perfect meal using Gorobi. So to start, for the background, the focus of this work is meal planning for nutritional health and cost efficiency, linear programming to minimize meal costs while meeting nutritional requirements. For the objectives, first is to develop and evaluate practical, cost-effective, time-efficient meal plans for different dietary needs. Example are deficiencies in iron, vitamin D, and calorie intake. Second is to correlate nutritional requirements with meal cost and portion sizes. So meal planning is crucial for health but can be costly and inefficient due to the challenge of balancing nutrition and budget. So this study addresses this issue by applying linear programming, a mathematical optimization technique to minimize meal costs while meeting specific nutritional requirements. So for the methods, first we have the dataset. It contains nutritional values of various foods. Second are the constraints, the nutrient ratios and fractional weights. Third is objective function, minimizes meal costs while ensuring nutritional requirements are met. And lastly, the software used is Gurobi. It is a software library for linear programming calculations. So for the mathematically, the objective functions for maximizing nutrient values and minimizing prices, all with certain constraints, can be expressed as follows. For the maximization of nutrient value, for the minimization of price, and for constraints, fractional weights and nutrient ratios have all been given specific formulas to be used. Now for the results. For the first graph, after getting the result from Groby, a scatter plot was created to compare meal weight and dietary preference. The results show that nutritional needs significantly affect portion sizes, with the vitamin D deficiency meal being the heaviest at 1,039.33 grams, and the optimal case being the lightest at 783.27 grams. This suggests that diets addressing specific deficiencies require larger portions to meet nutritional requirements. For the second graph, a bar graph was also generated to compare meal costs across different dietary needs. So the results show that the vitamin D deficiency is the most expensive at $12.30, while the average optimized meal cost $5.84, representing the minimum possible daily expense for balanced nutrition. The graph highlights that specialized diets, particularly those addressing deficiencies, tend to have higher costs due to the need for more expensive ingredients. Now, for the significance, scope, and limitations. First, for the significance, it helps create economical and well-balanced diet plans. Second, for the scope, linear programming, case studies for dietary needs and dietary constraints. Lastly, for limitations, dataset and ingredients availability. So the significance of the study is that it can help people create economical, well-balanced diet plans that take calorie requirements and fitness objectives into account. By highlighting the relationship between nutrition, optimization, and practical application, the study helps with effective, sustainable, and time-sensitive meal planning. The scope of the study includes the use of linear programming to optimize meal planning, the analysis of case studies for different dietary needs, and the application of constraints such as nutrient requirements and costs of ingredients. However, the study is limited by the data set used, which may not include all possible ingredients, and by the constraints applied, which may not fully account for custom dietary preferences or real-world food availability. Now, for the use of mathematics, first is the optimization technique, linear programming, or using Gurobi. So the benefit is the precise and more efficient than trial and error methods. And for the data representation, tables and graphs, and the benefit of it makes result comparison, analysis, and visualization easier and clearer. So this study uses mathematical concepts, particularly linear programming, to optimize planning using the Gurobi software. This method allows for the consideration of numerous variables and constraints simultaneously, which provides precise and practical solutions that would be challenging to achieve through heuristic or trial and error methods. Furthermore, tables and graphs help represent numerical results more clearly, making it easier to compare meal plans, analyze trends, and visualize the impact of dietary constraints on cost nutrition. For the role of mathematics in the field, first, it is essential for solving real-world problems in nutrition and health. Its applications include healthcare resource allocation, personalized dietary planning, and third, modeling public health policies. Mathematics play a vital role in the field of nutrition and health by providing methods and tools to solve complex real-world problems. The study demonstrates how linear programming became instrumental in optimizing highly nutritious and cost-effective meal plans. This highlights the importance of mathematics in the said fields, where optimization and data analysis are crucial for developing efficient, sustainable, and personalized solutions. Mathematical methods can also be applied to healthcare resource allocation, personalized dietary plans, and modeling public health policies to predict disease spread and evaluate intervention strategies. So this concludes our presentation for today. Thank you very much for listening.
We also have here Maria Elisa Baldaza Herradura, ABS Nutrition graduate from UPLB, to answer some of our questions.
So, good afternoon. So, first question, what is the role of mathematics in creating diet plans for clients? So, we use math to calculate the ideal weight, the body mass index, the calories needed by the client or by the patient, the right proportion and percentage of carbohydrates, protein, and fats needed by the individual, and the distribution of the calculated amounts into meals. So, yung atin kasing calories, the carbohydrates, may certain percentage yan, pati the protein and the fat, and then we will base it on the weight of the patient, kung ano yung condition niya, and then kung kailangan ba niya mag-reduce ng weight, kung ano yung mga bawal sa kanya, at kung ano yung mga modifications na gagawin sa kanyang diet. Now, how do you calculate the right amount of nutrients like proteins, fats, and carbs for a client? So, again, sabi ko nga kanina, it will depend on the weight and the condition of the patient. So, there's a certain percentage that we follow. For example, sa carbohydrates, we have to put or allot 45 to 65% of the total calories. And then sa protein is around 10 to 35%. And sa fat is 20 to 35%. So, kung halimbawa yung patient ay overweight, we have to deduct 500 calories from the amount of energy na pwedeng ibigay sa kanya or for the amount of calories na na-compute para sa kanya. So, para to lose weight, we have to deduct 500 calories. Now, for patients with certain conditions, like halimbawa, meron siyang low salt, no fat, low protein, gagamitin natin yung lower percentage na nakaalat dun sa kanyang prescription. So, what are some important mathematical skills needed for someone entering the field of nutrition? Actually, it's just basic math. We are just using the addition, multiplication, the division, and then the conversion into metric or the conversion of inches to centimeters. So, basic math ang kailangan natin lang sa pagko-compute ng mga diet. So, if an individual has a certain disease, how can you utilize math to modify their eating plan? So, again, there is an assigned percentage. Now, usually, ang doktor ang nagbibigay ng prescription. Ang role ng nutritionist is to compute based from the given allowance ng doktor. So, halimbawa, in order niya na 60% lang ibibigay sa carbohydrates, and so and so. And then, after you compute dun sa mga calories na ma-derive mo from the prescription, you will convert it into meals. So, kung ilang meals yung ibibigay, kung ilang grams ang ibibigay dun sa tao, and so forth, so on and so forth. Now, what mathematical models you usually use in the field? Usually, we are following a certain table. Meron kaming tinatawag na food exchange list, wherein nandun makikita mo kung ano yung mga pwedeng food na pwedeng ibigay sa isang individual. This is a certain percentage na binigay sa kanya. So, pag sinabing low salt, ito lang yung mga recommended na meat. Low fat, ito lang ang pwede mong ibigay. No sugar, etc. So, on a scale of 1 to 10, how would you rate the importance of mathematics in analyzing dietary data and making meal recommendations? So, I think it's around 9 to 10 yung importance ng math sa pag-a-analyze ng mga meals recommended by the doctor.
Why?
Why? Then, because we use a lot of math. Although it's just basic math, pero kasi yung math na yun may i-apply namin doon sa pagko-compute ng kanilang mga diet.